and how it's connected to many of the different things that we need to understand. First off, a t-test is a statistical test that helps us to determine if the means of two populations are significantly different. In other words, this is a judgment about how close the means are to each other. We can view this using standard deviation or range and error bars and the means graphed here that you can see. We can see that there is some overlap if we look at the standard deviations of the actual the two means here. However, we want to know if they're statistically different. So t-test actually gives us a probability about whether or not the two means are the same. Specifically, we're looking at if the probability of two means being the same is equal to 1, this means that the two sets of data are exactly the same. In other words, they're basically the same information and there is no difference between them. If probability is equal to 0, then the two sets of data are not at all the same. So this means that the two sets are so drastically different that there is no overlap at all in the data sets at all. Anytime we run a t-test, we're looking for that probability statistic. Anytime you run something on Excel with a t-test, it's going to give you that probability factor. Please realize that this is different than doing a t-test by hand, but for our purposes, we're just going to learn how to use it doing Excel. Anytime you do a t-test, you start with the null hypothesis. The null hypothesis states that there is no significant difference in the means. In other words, we're trying to say that the two means are basically the same, aka that the probability is equal to 1. In order our point of exception or rejection of this null hypothesis is 5% or 0.05. Oops. To accept the null hypothesis, we want to have that probability being basically 95% to higher than 95% or higher than 5% that there is a statistical difference. In order to reject it, to say that there is a statistical difference between the two means, we want it to be less than 5% similar. So to accept, P needs to be greater than 0.05, and to reject, P needs to be less than 0.05. Now that we kind of understand what a t-test is, we're going to run the t-test using Excel. Remember, a t-test gives us P, or the probability. Just like you would, equals, we're going to insert our t-test formula. T-tests are kind of a little bit more difficult to do than your simple average or whatever. So I'm actually going to click this formula builder, and this actually tells me what I'm actually running on. An array is the set of data. So I have two sets of data, array 1 and array 2. The tails, as you can see here, we're going to look at a two-tail distribution, and the type we're looking for equal variance. So how close is it equal? We hit enter, and that gives us the probability that these two sets of data are the same. We can see that P is much, much lower than 0.05. Therefore, we are going to reject the null hypothesis. We can also see that this number, we can see from our graph over here that these points are actually, there's not much overlap here, and it's pretty easy to tell that there probably is no statistical difference. However, again, a t-test gives us an actual numerical number that we can use in an evaluation to state that there is a statistical difference between the two. Thanks for stopping by.